I am Anil Kumar. Welcome to my series on vectors in space. We have some concepts about vectors in 2D, representing them on Cartesian plane and finding distance and also the angle. In this video, we will see how we can connect with those concepts and move on with 3D space. How do we represent these vectors in space? How do we write the vectors with ijk, find their magnitude, unit vectors, and the direction cosine? Let us connect with what we know to where we want to go. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Amy. Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Good, good. So today, what do you want to learn?
I was hoping if we could actually start a new chapter in terms of vectors as a whole. Over the previous years and just doing vectors, I've always kind of struggled. I don't know why. I feel like the concept for me and all the foundation is definitely just not there. It's just, yeah, kind of all over the place. So I was hoping if you could just, clarify everything and kind of start from the basics and kind of, move upwards in terms of from 2D to 3D and then, yeah, so on.
So why don't you share what you have, and then from there I'll pick it up.
Okay, cool. So yeah, in my textbook they have I think they start on in terms of 3D. They did start on the distance formula and using that.
Let's start from the beginning. Okay, so that is your vectors. 3D coordinate systems you are working on. Okay, trying to find the distance between 2 points.
Oh, sorry, the distance between the points. Yeah. In this case, there's 3 points. So is it because of the three? Because it's 3D now. Is that why?
Correct.
Oh, okay. And then yeah, vectors in 3D.
Right. So this is scalar product. When you say 2a minus 3b, you multiply the vector a by 2 and b by 3 and then do those vector operations. Correct. Okay. And then you are finding angle of the vector with the axis. So that is all direction cosines. Fine. So that's good. So we can look into these. I'll begin with 2D and then move to 3D, and then we'll work with 3D as you are showing on the screen. Is it okay?
Yeah.
So I'll just show it. I'll start from the basics. So I'll share with you a whiteboard, and then we'll begin with vectors. Is it okay? So as you said, you're not fresh with the knowledge of vectors. So let's begin with beginning, right? So vectors. So what are vectors? So two things. They have direction and magnitude. If there is only magnitude, we call those things as scalars, right? You remember scalars? Yep. Only magnitude. Okay. So let's give some examples to begin with. Some scalars, some vectors. So vectors and scalars. For example, If I say distance, what do you think? Distance is scalar or vector?
Scalar.
So what is the vector counterpart of distance?
Displacement.
Similarly, we have speed and velocity, right?
Mhm.
So now you can appreciate when we say speed, 60 kilometers per hour, whatever may be the direction, just 60 kilometers per hour. What if we say velocity? We define 60 kilometers per hour going north, and we consider
Right.
north or east as positive velocities and west and south as negative velocities most of the time. Right? Acceleration, for example, we have seen is a scalar vector quantity.
Is force also one vector?
Okay, so many, for example, force, yeah, torque, you learned about,
Oh yeah.
right? So moments. So those are your scalar quantities, vector quantities. So that is how we will see temperature. What is temperature?
Scalar. Yeah. Doesn't direction. Yeah, I don't think so. So
Mass and weight. Very important. Mass and weight. So when we say mass, it is the matter contained in the body, right? Mass remains constant whether you are on the earth or on the moon.
right.
However, the weight is different because it is the force with which your body is attracted towards the earth, right? Or the surface, right? So
Yeah.
gravitation pull is much lower on, for example, on the moon, and therefore the weight will be less. Even inside the water, you will feel lighter, correct? Because
Yeah.
of point force. So weight is a vector quantity and mass is a scalar quantity. So that is just to give you some idea about scalars and vectors. Now let's move on to vectors. So vectors, you showed me all the pages with 3D, but we'll first consider 2D. So when we say 2D vectors, basically we are saying we are only resolving each force or each vector in two components, one along the x-axis and the other along the y-axis.
Yeah.
So let us say we also define another vector along these axes, which just gives you direction and a magnitude of one unit, I. So vector I, written with a small cap on the top, is a unit vector along x.
So what's the cap for?
Just to say, vector is written as, if I have to write, for example, A as a vector, I will write either a bar on the top or I will write A bold. When you type in bold, it becomes a vector, correct?
Mm-hmm.
So there are many ways of writing vectors. Sometimes we also write a vector with a line saying some direction. Is it okay? Some direction. So unit vector, we put a cap saying its magnitude is 1. It is a vector, but its magnitude is 1. Okay.
Oh,
So
okay.
unit vector.
So the symbol for a unit vector needs a hat on top.
Yes. So this is I, and J is a cap unit vector along y direction.
But to be a unit vector, does it need to be one, or can be anything, like any number?
Unit means magnitude is 1. Is it okay? So for example, if I have to show a vector which is 5 units long, for example, let us say my vector A is equal to 5 units long, magnitude is 5, and it is along the x direction. I could write this as 5I. So that gives me the magnitude of 5 and direction of I. You get the idea?
Yeah, yeah.
If I have another vector B, let us say B vector is, let's say 4, right? And J means I have this vector along y direction. You get the idea?
But if it was just I without the hat, doesn't that also mean 5 magnitude, or it doesn't?
Yeah, I basically means unit vector along x-axis. Correct. So you may or may not write that. Yeah.
Okay.
Agree. But what happens normally when you write on the screen, you cannot make them bold.
Yeah.
When it is given in the book, anything bold you understand as a vector, correct?
Right.
You don't even have to write a line on top of it
No. Yeah. It's really
because it
clear.
is
Yeah.
bold, right? Now, when you're typing or writing on the screen, I cannot write it bold easily, right? So I have to.
Yeah.
So in that case,
Go
I have to
over
put
it.
a hat on it. It's a convention.
Oh, I see.
So
Yeah.
now, as you rightly pointed out, I and j, if I write, it will means unit vector. Is it okay?
Hmm.
Strictly, when we write this in the book, they will be bold, and otherwise we'll have something on the top of it which is like a hat. Is it okay?
I see. Yeah. It's because when at school when we make it bold, we just put a line underneath. But then the hat, it thought it meant something different. So that's the notation just for unit vector. That's separate
Yes.
from making it bold. Okay.
Hat means a unit vector.
Oh, okay. So yeah, I did. Yeah, I didn't know that. Okay, cool.
Right.
Got it.
So now I've shown you two vectors. One is I'm saying vector 5i. So let me write down this vector as 5i. We just means I'm not writing now hat and 4j, right? So now 5i is a vector along x-axis in the direction of x positive axis with a magnitude of 5, and 4j is a vector with magnitude of 4 along y-axis facing north. So we'll also say this direction is north and this is east for us many times. Is it okay?
Yeah.
We consider both of these directions as positive. Now with vectors, you can do addition, subtraction, and all many things. Right? So for example, if I write a vector C, which is combination of these two, so combination could be 5i plus 4j. So it is like adding them up. So let us say you go 5i units. So that means you go 5i in this direction along this, and then 4j, and you reach this point. So you started from a point O and you reach a point, and that vector is C. You see that?
Yeah.
So now we have added actually the vectors. We got a vector C, which is 5i plus 4j. You can now find both magnitude and direction of this vector. Magnitude using Pythagorean theorem.
5 squared.
So the magnitude will be written with the absolute value. It's always positive. 5 squared plus 4 squared squared. Is it okay?
Yeah.
How much do you get?
25 plus 16 is 41. Square root 41.
Square root 41. Now the question comes, what is the direction of this vector? Because when we talk about vectors, we always say vectors have magnitude and direction. So
Yeah.
what is the direction of this particular vector? So when you have
Northeast.
2D, you can find the direction using tan theta, for example, because the magnitudes are known to you, correct?
Wait, so when they mean direction, they want you to find the angle?
So yeah, you have to find the angle. This angle you could find from x-axis or from y-axis. You need to specify. Is that
so you can't just be like northeast and be like, okay.
So yeah, you could say northeast, but then you're specifying from north that much east. You're getting my point. One and the same.
Oh, okay. Oh, yeah. So the angle again. Yeah.
Angle, yeah. So we say, in this case, we say what is tan theta equals to? Tan theta is 4 over 5, correct? So theta is tan inverse of 4 over 5. Can you use calculator? Find this out in degrees.
Yeah. Degrees. Sorry, currently in radians. 38.65.
Okay, let's take 38.7.
37. Yeah.
So we could even round it 38.7. So now we say that this vector C is, now let us see convention of putting this. You could now say in many different ways. So from east, so many degrees north it is, correct?
Mm-hmm.
So let me go to a fresh page. Let's again do it on the side. So what we just figured out is we are trying to do vector addition in 2D. So we have one vector, which is the addition of two vectors. So we have vector C, which is equal to vector A plus vector B, where vector A is 5i and vector B is 4j. Now the magnitude of C is basically equal to 5 squared plus 4 square root, which is square root of 41, right? 25 plus 16. Now the direction, we are saying let this angle be theta. So in that case, we know tan theta can be written as 4 over 5. And therefore, this implies that theta is equals to tan inverse of 4 over 5, which you calculated as
38.7.
38.7. Let me round it to 39. Is it okay?
Yeah.
So that is the theta. Now, how do I say this angle for the vector? This is another
Yeah.
thing which we need to figure out, right? So we have these vectors here, A, B, and C. So vector C can be written in many different ways. We could adopt a bearing angle. So bearing angle is always from north.
Yeah.
So how many degrees from north? So in this case, we know that the bearing angle of C is 90 minus 39, correct?
Yeah.
How much do you get?
51,051.
051 degrees. Bearing angle is always written in 3 places. Is it okay?
Yeah.
So we know it's at bearing of. So you say vector C. So we say vector C has magnitude of square root 41 and bearing of 051 degrees. Or you could also say that this vector, as far as the direction is concerned, you could also give a direction from east, right? Or from east also you could write from east 39
Point.
degrees north. Is it okay?
Yeah.
You could say that. You could also say from north, it is what the bearing angle was, 51 degrees east. Is it okay?
Yeah.
So these are different ways of showing the vector in 2D. Right?
That's clear.
Right. So now let's look into writing the vector. Okay, we'll go into 3D and then get into other concepts. So 2D is okay? Clear to you?
Yeah. Yeah. Really clear.
Now let's look into 3D. So when we talk about 3D, it is like corner of your room. So that gives you a 3D figure, right?
Mm.
And here we have X, Y, Z axis. So we'll just extend the concept. So now we have a vector along this unit vector I, J, and K. So that is my unit vector IJK. Do you see that? In
Yeah.
3 directions, right? So as I was saying, normally we may write it as with a cap also. In books, they are written in bold. And as you understand, all these axes are at right angles, correct? So these axes, they are all at right angles. Correct? So you can apply Pythagorean theorem to find the length of any vector when represented in 3D. Is it okay?
Yeah.
So for example, now let's take a vector, which is vector P. And vector P is written as, let us say, 2I plus 3j plus 4k. Okay. So we have written a vector 2I, 3j, and 4k. Let us first see how do we represent this in 3D space.
Yeah.
So basically, 2I means you move 2 units along I direction. Is it okay? That is I.
Yeah.
3j means go 3 units along Y direction. 1, 2, and 3. Do you see that? 3. So basically, what we can do now at this stage is kind of make the base of our 3D figure.
Yeah.
So we can make a rectangular prism. And then we have to move 4 units up. So 4 units up, let's say this is my 4 units up, right? So when I come to this point, that is my vector, which is P. So I can now say that the vector P is starting from the origin, and that is the point P. You get the idea?
Yeah.
So while moving along the axis, these unit vectors multiplied by a scalar quantity in each direction gives us the net result, which you can see here. You can actually complete this diagram, and what will it form? So let's complete this diagram. So we have this. You can go from here also. Right. So I just made a box to give you a 3D picture of what this vector P is. Is that okay now?
Yeah.
So each vertex of this can be given a Cartesian point. If you are on the x-axis alone, in that case, you did not move along y or z, correct?
Yeah.
So this coordinate point here is 2 and the other values are 0. At this position, you moved along y 3 units and therefore the coordinate points are 2, 3, 0. Is it okay? And when you went up, you came to the point 2, 3, 4. Does it make sense to you?
Yeah.
What will be the coordinate point of this? You could come directly to y without moving along x or z, right?
Mm.
So that coordinate point will be 0 and y value of 3 and 0 for this, correct?
Yeah.
Right. So, because see, if I go along this, I go 2 positive I and this 3 and then 2 negative I. You see, I read y.
Oh. Yeah. Yeah.
So that 2 positive
Because you
negative
go
cancel.
backwards.
I could have
Yeah.
added also, no problem. Is that okay?
Yeah. Yeah.
So this point here will be what? So from here, we went up 4 units. So it'd be 0, 3, 4. Now, when I'm writing 0, 3, 4, I am in, oh, this is Z, sorry, sir, this is Z, X, Y, Z axis, correct? X, Y, Z axis,
Oh. Yeah.
X, Y. So look here, when I'm at this particular point, which is this plane, I have 0, 3, 4. So the point 0, 3, 4 is in which plane? It is in YZ plane. You see?
YZ034. Yeah.
It did not move along. It is like the wall opposite to you when you're sitting. That point
Right.
lies on that wall. So
Yeah. So that one didn't touch the X plane at all.
yeah.
Yeah.
And if you look into this plane, which is the floor, you see the Z values are 0.
Yeah.
So that means if I give you a coordinate point, which is, for example, some value A, B, and 0, it simply means that this point is where? This point is on XY plane.
Okay. Yeah.
You get the idea. So you did not move in that direction. That means you did not actually were in that plane. Get the idea.
Okay.
It becomes
Yeah.
a 2D figure then.
That makes sense. So if it is 0 in like the coordinate, it means that you didn't move in the plane that it was 0 in.
Correct. Correct.
Okay.
So, and that also gives you one more thing. It is to find the X, Y, and Z intercepts. So when I say find the X intercept, it means both Y and Z are 0, right?
Yeah.
Y intercept will be 0, B 0. Is it okay now? So sometimes the questions will ask such things, right? What is the x-intercept of this? What is the y-intercept of this? Especially when we move on with planes and intersections, so that gives you an idea where that vector is. Is that okay?
Yeah.
In the space. So that's kind of an overview of looking into all this. Now, let us also find the magnitude of this vector, correct? So let me go to the fresh page and we'll see how do we find magnitude of the vector, right? So basically, we have made a rectangular prism. You see that in doing all that? So let me just make independent. So whenever you are representing a vector in 3D, always this is called octants.
Oh, octants.
Yeah.
Oh, okay.
So now let us say that the vector is moving in such a way that this is my origin. Is it okay? Let me just
Yeah.
say my origin. So I want to make it in a different line. When you're working with vectors, you have to draw neat and clean diagrams.
Yeah.
So vector basically has magnitude direction. So if you draw it nicely, you really understand it. Is that okay?
Right. Yeah.
Very important, right? So I'm taking my time to draw. It is important.
Is X always in that direction?
Yes. So in 3D, it's good to have a standard, and this is what is followed globally.
Okay. Yeah.
So XY plane is like floor of your room. YZ plane is right across, and XZ plane is on your left side. Is that clear to you?
Yeah.
So you can visualize where each vector lies. Right? Anything
Right.
going in between is going in the vector space of 3D, right? Just
Okay.
as now we are saying let this be A00, so you understand now. And this point here is AB, right? 0, right? And we came to this point, which is my vector ABC, right? Right?
Yeah.
Now, if I have to find this particular distance ABC, how will I find? So first step will definitely be to figure out this distance, right? So that is my vector. Is that okay now?
Oh.
So clearly, when we're talking about this is right angles, correct?
Yeah.
Where each side is A and B, and therefore that direction is how much? A square, let's say O, let's just call this as A, B, and we'll call this as C, right? So OB basically is equal to square root of A square plus B square. Yeah.
Yeah.
Now, basically, I need to figure out what is my net distance from here, right? So when we talk about displacement, we talk about starting point and the end points.
Yeah.
Starting point is at the origin, end point is at C. Now, to find this particular distance, that I know, and this I know is at right angles, right? And this height is C. So therefore, O to C is basically equals to square root of OB square plus BC square, right?
Yeah.
So square of OB square is what? A square plus B square whole square, which is A square plus B square, and BC square is C square. Do you see that? So
Yeah.
we get this direction as square root of A square plus B square plus C square. You get the idea.
Oh. Okay.
So that becomes the magnitude of a vector. And whenever we position a vector with the origin, we call this as a position vector.
It has to be with the origin.
Yeah, position vector. So that brings me to something very important, which I did not tell you initially, is that vectors are only defined by two things, and these two things are magnitude and direction, not the
Right.
position, right? However, what I'm trying to say here is that if I have two vectors, right? Let's say this is my one vector and that is another vector. Both are at different places.
Right.
But if their magnitude and direction is, let's say magnitude is 5 and both are going northeast, then both are same vectors, equal vectors. So position doesn't matter. If I draw OC here, those vectors OC and OC dash are same vectors. Their position may be different, doesn't matter.
Oh. Okay.
For
So
convenience, yes.
And so to make them equal, it's not about them being like, the whole like parallel and everything
No, fixed. No, you don't
fixed
have
or
to
anything like that. You can
no
have free vectors.
free vectors. These are called fixed vectors.
Oh,
Could be
okay.
fixed
So,
vectors, and with the origin, if you fix it, then it becomes a position vector. Now, do you get this?
oh, I
Otherwise,
see.
vectors are free vectors. You could use that term also.
Okay. Yeah.
Is that clear to you?
Mhm.
Now, we have understood how do we find the magnitude of a vector, correct?
Yeah.
Now, the thing is, how do we find the direction of the vector? That is the next part, isn't it?
Yeah.
So
So
now
is
let's
that where the angles are being introduced?
yes. Now the angles will be introduced, right? So this part is clear to you, right? So if you have
Yeah.
any vector, you can easily find its magnitude. For example, if I have a vector, let's say n, so n vector is 3i minus 2j plus k, right? So in that case, what is the magnitude of n?
3 squared plus minus 2 whole squared plus 1 squared.
So I'm just writing minus because it's like it will get.
Yeah, okay. Just being all technical.
So that is the magnitude. However, now in 3D, it becomes difficult for us to define the direction of this vector. So
Right.
how do we do it? We call that as a direction cosines. So let us say we have a vector. Let's say this is my vectors. Let's call this vector OP. This vector OP, I'm making things very simple because we are used to working with 2D. However, we are working with 3D at present, right?
Yeah.
X, Y, and Z. So we could define it with respect to any axis. We could
Okay.
define the direction from x-axis, from y-axis, or from z-axis.
Right. Mhm.
We call them, I'll give the name later. Let's find out how. So normally we say direction from any axis. So terminology is that we say angles are alpha, beta, and gamma, where alpha is from x-axis, beta is from y-axis, and gamma is from z-axis. Is it okay?
Yeah.
So let's say beta is my angle and I want to measure this angle from y-axis. Is that clear to you? So see that.
Yeah.
So OP, I know this is the magnitude of OP, right? And let
Yeah.
us say that the vector is ABC. That means that from the origin in y direction, you move b distance, correct? You remember 0, b0?
Yeah.
Now, trigonometric ratio, what is cos of beta equals to? Let's call this point as m. So OP over OM over OP, right?
Yeah.
Which is magnitude B over magnitude of vector OP. Is it okay? Is it okay?
So OM over OP. Yep, so that's
So
simple
beta is
cos.
cos inverse of B over OP.
Oh, yeah.
Is
So
that okay?
yeah.
So basically, if I have a vector P equals to AI plus BJ plus CK, in that case, its direction from y-axis is magnitude B. B is a scalar quantity. B divided by the magnitude of the vector itself, which is a square
Yeah.
plus b square plus c square. You get the idea.
Yeah.
So, and since it is in terms of cosine, we call them direction cosines.
Oh, so are they always in relation with cosine?
Yes.
Like however you draw it.
Yes.
Oh, okay.
So these are called direction cosines. Is that okay?
Yeah.
If I have to see, this is from this diagram, this is my gamma and this angle here is alpha. You understand?
Yeah.
So that is how it is. Now it looks very simple to, in this particular situation, explain the concept using y-axis. And therefore
Yeah.
in the books and most of the time, we use y-axis. Is that clear to you?
Yeah. Yeah.
So let's clear it. So basically, if I have a vector, let's say vector v, which is equals to ai plus bj plus ck. In that case, the magnitude of vector is equal to a square plus b square plus c square. And direction cosines alpha is equals to cos inverse of a over magnitude of v, correct? Beta is cos inverse b over magnitude of v, and gamma is cos inverse c over magnitude of v. Is it okay? Clear?
Yeah.
Now, very important relation from all this is, you know all this, right? I could have written cos alpha is this, right? Let me write down another way. Cos alpha is what? Cos alpha is a over magnitude of v, correct?
Yeah.
Cos beta
Cos
is
of
b
B
over
over,
magnitude of v,
yeah,
and cos gamma is c over
C over
magnitude of v.
magnitude V.
What is cos square alpha plus cos square beta plus cos square gamma? Can you tell me?
V magnitude V. Oh no.
Tell me.
Oh, just a square of all of them.
Square, yeah, each square individually.
Oh, okay. V and then C over magnitude V whole squared.
What do you get?
A squared plus B squared plus C squared over V magnitude squared.
Which is a square plus b square plus c square. Do you see that?
Oh yeah. Yeah, when
Which
you
is
cross
this?
multiply. That's what I said from there. I thought you were eventually going to go back to that.
Yeah. So you
Yeah.
just square this, right? So
Uh-huh.
the direction cosine square sum is always 1. So remember that part. Very important for solving many questions.
Oh, okay. Can I just write that down quickly? So cos squared alpha plus cos squared beta plus cos squared gamma. I never know how to draw the gamma symbol.
Okay.
Equals
It's
1.
like R. Like a
Oh,
bird.
like an R. Okay.
R or a bird. Bird flying, right?
Oh, cool. Yeah, yeah. All right. So that's really important.
Clear? So with this, we understand what 3D vectors representation is.
Yeah.
And how do we find the magnitude and the direction. Now we can take any question from that chapter which you showed to me, right? So let's go through the book, okay? So
All right.
is this all clear to you?
Yeah, very clear.
Perfect. So why don't you share the screen? We'll quickly go through the examples and some questions from your book now.
Okay.
Yes, please. Example 4. Oh, anywhere. Open. Yeah, example 1. Okay, exercise. Let's go through the exercise, right? So
Yeah.
exercise 1. You can do this question now.
Question 5. Let's attempt.
So when they say
So-
distance from the origin means position vector, correct?
Position vector. Yeah.
So you know it
Fixed.
is 2 square plus 8 square plus, you can write minus 4 square, correct? And
Yeah.
calculate. Next. Find the distance from origin of this point, right? So you can take 7 square common, right? So this is interesting only because you have 7 square common. Is it okay? 1 plus 1 plus 1, correct? Square root, correct? So you get 7 square root 3.
Oh.
Just as
Yeah.
when you have a, 2D, you get square root 2, right? A square plus a square is a outside square root 2. So same thing, correct? Next.
All right. Okay.
Find the distance between any 2 points. So this is the distance formula, which is basically x2 minus x1 whole square plus y2 minus y1 whole square plus z2
Z2.
minus z1 whole square.
Square root.
So you can use this formula, get the book. Is it okay? Yeah.
That's cool. And then here is just an unknown variable, make it equal to 3 root 10, and so on.
And then you square both sides and get your answer. So basically, the coordinates of this and this are given to you, and then just square and get the answer. Is it okay?
Yeah.
So better in this cases, let me just do it for you. We can say k minus 7 whole square plus 0 minus 1 with minus 1 makes it plus 1, and 4 minus 2. 4 minus 2 whole square is equal to, the distance between them is 3 units. So write 3 square. Write 3 square. So you do not have to write square root. You get my point?
Right. Because you cancel it by squaring.
Cancel. Yeah. So now when you solve it, k minus 7 square, try to solve without opening this bracket. Let me show you. 3 square is 9, right? And these terms, when they go on the right side, this is like minus 1.
4
and
minus
4, right? So which is what? 9, 8 minus 4 is 4. Do you see that?
Yeah.
So k minus 7 will be plus minus square root of 4. Do you see how easily it gets? Which is plus and minus 2. And therefore, k will be 7 plus minus 2. So we get two possible values of k, which could be 9 and 5. You get the solution now. I did not expand k minus 7 whole square. In the book or in the test, many times when they give you this kind of a question, then you have an exact value which could be figured out without expanding and complicated, right? Normally what a student will do, expand. They will do all that. Expand k square minus 14k, right?
Plus so just 49. A quick thing, where did the so 9 minus 1 plus 4 equals 4?
Okay, let me go through one step here. We'll go up from here, right? So we have this k minus 7 whole square plus 1, that is 1 square, and 4 minus 2 is 2 plus 4 equals to 9. Is that okay?
Yeah.
So I took 1 and 4 on the other side. You could, this should be minus 4. That's what you think. Sorry. I wrote plus, but I meant minus in my mind.
Oh, okay. Yeah.
Okay, sorry for that.
Okay, yeah, that's all right. Okay, makes sense. Clear. Yeah.
So when you take 1 and 4 on the other side, correct? They become negative. 5 negative. Yeah. 9. So 9 minus 5 is 4, and square root of 4 is plus minus is very important. Do you see that?
Square root.
Possible values. So find possible values. Do you see that S here?
So they're helping you, guiding you to say that there's more than one answer. Yeah.
Otherwise, you get half the marks, right? So that's how you should be answering this question, correct? So let's look into the challenge question, please. What is? Can you read this?
The points A, 1, 3, and minus 2, B, 1, 3, 4, and C, 7, minus 3, 4 are 3 vertices of the solid cube. Write down the coordinates of the remaining 5. So that's exactly what you were saying here in terms of A, B, and C. A, B,
add
0.
Add them. Right? I'm not saying this is a straight line means it is a, I'm not saying this axis is along x, y, z, right? But more or less, right? And this is my C, and points A and B, I'm saying A is 1, 3, 4, and B is, A is 1, 3 minus 2, and B is 1, 3, 4. So I'm taking this as 1, 3, A as 1, 3 minus 2, and this being B as 1, 3.
Oh, I see. And the 7 is further out. Yeah.
Correct. Now, that is right. Now, one thing again we have to figure out, if I make like this, what is the distance between these 2 points? Can you please calculate distance between AB and BC?
Yeah. So AB and BC.
The first AB.
Oh, okay. So 1 minus 1.
0.
Whole squared plus 3 minus 3. 4, 0. And then minus 2, 4 minus 4 is, no, minus 2 whole squared is 4.
4 minus 16. 6. So this is 6, correct? 4 minus 2 means 6. 6 squared, correct? So it is 6.
Yes, right. Yeah, that is 6.
Now find what is BC.
6 square root.
Find what is BC.
Okay, so BC is 1 minus 7, so that's 6 squared. 3 minus 3, 0. 4 minus 4,
No,
0.
no, no, no. When you do 3 minus, it is minus 3 minus
Oh, 9.
again
No, 6
6,
squared.
again 6 square, right? And then
Yeah.
4
4
minus
minus 4,
0, right?
0.
You understand? So this
Sorry,
is
negative.
square root 2. Do you see that 6 square root 2?
Yeah.
6 square root 2 clearly means that this is diagonal, right? On the top. You understand? Now, do you understand? These two sides are square and that is diagonally positioned. C is diagonally positioned, not along the other position. You understand now?
Right.
So from the distance, we verified this is 6, right? And this is 6 square root 2. And that becomes my point C.
Oh, okay.
Now from here, I can actually give you all the points. How? Because I can now move to this point 1, 3, 4. So 3 and 4, I have to go 3 units. This is 6 units, correct? So this point here, let me call this point as D, will be 1 unit along the X itself because we moved out C, correct?
Yeah.
However, it is minus 3. We are along this direction and it is still on the top. Do you see I got point D without calculations?
Yeah. So is that what they require us without,
Yes,
calculating every
yes.
point? Oh,
So
okay.
you do not have to calculate. If you get into calculation in vectors, it will be very difficult. Without calculation, I have given you point D, right?
Yeah.
Similarly, I can give you all the points because that point will be 1 minus 3, 0. 1 minus 3 minus 2 because it is in this plane. Is it okay?
Yeah.
So I'll write here E will be 1 minus 3 minus 2. Is it okay? Because it's in the down plane. This point, let's call this point as F. So point F for me is going to be, instead of 4, I will write minus 2. It is 7 minus 3 minus 2. You get the idea.
So it's the bottom plane minus 2.
Yeah.
Oh,
And this
okay.
is the top plane with 4. And to get this point, how do I get this point? This point is combination of these, right? So what should be the point? Only thing is we are moving X along 7. So let me call this point as G, for example. So let me write G here, right? So G, Y value being same as these two, right? So because it has moved X value same, which is 7, but the Y value is same as 3
Yeah.
and 4. You get the idea now?
Hmm.
You see, without calculation, I am giving you all the 8 points of the square.
Right.
Provided I'm able to sketch it properly just as I did.
Yeah. Yeah.
And that is the reason why it is a challenge question. Because otherwise, if you do not put the points in right perspective,
You can't figure
it
out.
is very difficult. It's a challenge question. But now when you do it, it is a simple question. You get the idea.
Yeah. So must sketch it on a grid
Must sketch on a grid.
for
After
accuracy.
you sketch on the grid, you will get an idea and read the points directly.
Right. Right.
Right? So that is how you are going to do. And then an ant walks from A to C along the surface of the cube. Determine the length of the shortest possible route the ant takes. So from A, the ant is going to C, right? So what is the shortest distance? A to C, right?
Hmm.
Along the cube. Ant cannot go along the, air, correct? So
Yeah.
what is the path? What is the path ant is going to
So
take?
it can go
Like this
if
and
you
then
find
up,
each
right?
F. Yeah, and then upward. Yeah.
Correct?
So that's the question we did before, where
Yeah,
you
so
find
that's
the
the
bottom
distance between
and
the
then
2
up.
points.
Yeah.
That's the distance between the 2 points. Is that clear to you now?
Very clear. That makes a lot of sense.
Yeah, so let me clear this and yeah, let's take more examples from the book. Yeah, move ahead with this exercise. What else do we have?
Oh, so these.
Correct. Now we are talking about direction cosines, correct?
Yeah.
Right. So example 6. Can you please read example 6?
This example, yeah. Find the magnitude of A, which equals 2I minus J plus 4K, and hence find A hat, the
Unit vector.
unit
Unit
vector
vector. Yeah.
in direction of A.
So when you find the unit vector, so in that case, you divide by the magnitude of the vector each component. You get the idea?
Okay. Yeah.
Divide by the vector each component. So the magnitude of A is 2 square plus minus 1 square plus 4 square. So 2 plus 1, 4 plus 1 plus 16, 17 and 4, 21 square root. So when you divide each coefficient by square root of 21, you get the unit vector. You get the idea?
Oh, yeah.
So that is how you get a unit vector. Correct? Now, unit vector is very important. Unit vector directly gives you the cosine angle. Do you see that?
Oh.
Yeah, because we have divided the magnitude by the ABC component, right?
Oh, wasn't that the formula that we wrote down?
Yeah,
where we
that's
said
the
cos
formula.
B is B over a magnitude
Correct.
OP. Oh.
So if I tell you this is my unit vector, in that case, from the unit vector, I can find direction cosines directly, right? For example, here, what is cos alpha equals to? Cos alpha is equal to 2 over square root 21. You get the idea?
So 2 came from...
When you multiply this distributive property, right? 2 over 21. Your vector is 2 over 21 minus 1 over square root 21 and 4 over square root 21. When you multiply this.
Yeah.
So cos alpha is 2 over square root 21. So what is alpha equals to? Cos inverse. Find out. Cos inverse of 2 divided by 21. You find the angle.
64.1.
So that is the angle which this vector makes with x-axis. You understand?
So do you mind just explaining the 2? So is that angle just with x because that's 2I?
Yeah.
So if I wanted to find in terms of the y direction, I'll do minus 1 over root 22.
So
21,
look into this section. So they have multiplied and written it in this yellow background. Do you see that highlighted?
Oh,
so
yeah.
2 over square root 21 is the coefficient of I in a unit vector. So that is actually the value for cos alpha. And the other value is cos beta. So cos beta is minus 1 over square root 21.
Yeah.
And cos gamma is 4 over square root 21. These three are called the direction cosines. Is that okay? So I could write the unit vector. See, A cap they have written, right? A cap is cos alpha I plus cos beta j plus cos gamma k. Can you correlate now with this?
Yeah, I can.
Exactly. You have given the direction along ijk, or this is a unit vector. Is that clear to you?
Along with the magnitude, which is given there. Yeah.
So
if you wanted to know the magnitude in the I direction, is it just 2 root 21I, or is it the whole thing?
Magnitude in the I for a unit vector, see, 1 plus 1 square plus 1 square plus 1 square square root is square root 3, not unit vector. You get the idea?
Right.
So because you are multiplying by cosine is always less than 1, it will give you the total magnitude as 1.
Oh.
If you have a cube, yes. Unit vector means that the length is 1. Each dimension could be separate, right?
Oh, right. Okay.
But a square plus b square plus c square is 1. That is what we
Okay. Yeah.
So we had proven last time cos square alpha plus cos square beta plus cos square gamma is how much? 1, right?
1. Yeah.
That is a unit vector.
I see. Okay.
That is
That's
your
clear.
unit vector. Is that clear to you now? So that magnitude is unit. So I think you have understood all this. That is what you have there. Anything else here in this chapter? Okay.
I mean,
so
I think
they have given the formula also, right?
Oh yeah, should I go back or is that all right?
It's okay. Here also they have given cos theta x. Can you read example 8, please? Why are we getting this screen? Can
In
we
this
remove it?
box.
Yeah.
Yeah.
Okay.
Not really sure about
Okay.
that. Did it just pop up randomly?
Don't worry. I can write there. I can use it. Don't worry.
Oh, okay.
Can you please read example 8?
Yeah. So the points A and B have position vectors 4i plus 2j plus 7k and 7i 4j minus k relative to a fixed origin. So it's a position vector. Find A, B, and show the triangle OAB is isosceles.
Correct. So basically, from one particular point, we have 2 points given to us, right? And it forms a triangle. O, A, B, right? So to
Yeah.
find A, B, what do? Just the difference, right? So we say A, B is equal to what? Basically, you can write this as 3 minus 4, 4 minus 2, and
Minus k
minus 1,
minus 7.
minus 1, minus 7. Now, this is
Yeah.
another notation. When I write like this, it means ijk components. Is it okay?
Okay, yeah.
So this is minus 1, that is 2, and this is minus 8. That becomes my vector AB. Is that clear to you?
Yeah.
They want find this and show that. And then they want the magnitude of this. So basically, I'll do square of these things. Is that okay?
Yeah.
So magnitude of AB is basically equal to square of 1 plus
Square of
square of
2.
2, which is 4, plus
Square
of
of 64.
Is that okay?
Yeah. Square root.
69 square root. Is that okay? So that is what O A to B is. Is that okay?
Yeah.
They've also got it square root 69, correct? Since they want you to verify whether this is an isosceles triangle or not, you find the other distances also. Origin being at 0, 0, 0. Is it okay?
Yeah.
When you calculate, you find two sides to be square root 69, and so you have shown it. Is that clear?
Yeah.
So that's how you do it. So let me clear this. So I think most of the things are clear to you, Amy?
Yeah.
Any questions?
No, I think that was really clear. I'll try and attempt all the exam questions from the first 2 chapters, since we've covered 3D vectors and also in terms of the direction cosines. So yeah, applying those 2, then hopefully I can get through those questions. Thank you so much.
Summarize today's learning, and then we'll end.
Yes. So we started off with learning just about the basics of vectors. So in terms of 2D vectors and just knowing the difference between vectors and scalar kind of quantities and the different categories that fall into them. There's some tricky ones such as mass and weight, trying to be aware of the differences between them. Then we moved on to 3D vectors, where you've got now 3 different planes. So you've got your x, you've got your y, and your z. And this is where we introduce our other variable k, so I, j, and k. We talked about unit vectors being like a over the magnitude of a, and doing that is on each individual basis of a, and then to find the cosines, direction cosines, you can do it directly from the unit vector in each direction, since it's all kind of given, and you just do cos of the different values. So yeah, that was really clear. And then we attempted a couple of questions there. So we saw with the challenge, in terms of drawing, it's important to sketch on a grid for accurate points, especially with vectors. Make sure to sketch so that just putting in that extra time to do so would benefit, because it's all about direction and magnitude. So you have to make sure you get both those things really precise.
Correct. Good. So we'll end the class here. Continue with your good work and share with me whatever difficulties you have in this. Okay.
Will do, sir. Thank you so much.
Thank you. Bye.
Appreciate it. Bye, sir.